Alright, so continuing with the infinite discontinuities, they come from a denominator that never cancels. So when we were doing our substitution and we would find those factors that cancel, the denominator doesn't in this case. Something does not go away. And what happens is, to find them, you have to set the denominator equal to 0 in order to find that discontinuity. And I'm probably just going to abbreviate discontinuity by DISC from this point forward in the notes, so don't be surprised to see that. So that is how infinite discontinuities happen. They happen because of vertical asymptotes. The next type of discontinuity is called a jump discontinuity. And as you can see by the picture over here with the graph, you've got a line going up to here, and then it just jumps to a completely different line and just picks up like they were never ever meant to be connected. And that happens quite frequently when you deal with piecewise functions. So these you'll see with piecewise functions with different left and right hand limits. So if you'll remember when we were doing limits, we would say this one would go to 2, but that one goes to -1, so the limit doesn't exist because the two sides don't agree. That's called a jump discontinuity. So this also can happen with specific absolute value equations or with step functions. And do you guys remember, it would be the greatest integer function, the ones that look like a staircase, those are the step functions. So examples of how this works. You could have an f of x equals x minus 1 and x plus 1. X minus 1 works for when x is less than or equal to 0, and x plus 1 works for when x is greater than 0. So this is an example of the piecewise. You could end up with y equals the absolute value of x minus 2 over x minus 2. Or y equals the absolute value of x over x, and this causes a jump right at that point of 2, or in that case 0. So that's the specific absolute value ones that cause those jump discontinuities. Or you could have your step function. Any of those would be examples of how to find this. And again, you would just have to go left hand versus right hand of a graph, or if it's given to you like this, you would have to go left hand versus right hand within your piecewise and compare the two limits, and at that break point, you'll be able to figure out where the discontinuity is. The last type of discontinuity is called a point discontinuity. And we've actually dealt with these quite frequently already. When we were doing the substitutions and we had to find the factor, because we were getting a 0 over 0, and you had to figure out which factor canceled, that 0 over 0 tells you that there is a point discontinuity. It's caused by a hole in the graph. So this is a rational function where the denominator cancels when you simplify it. So that's things like, for example, y equals x squared minus x minus 2 over x minus 2. Because this is going to factor into x minus 2, x plus 1 over x minus 2. So those will cancel, which means I have a point discontinuity at x equals 2. the one term that's gonna cancel, it created a hole. If you were to use another example, let's say this one's already factored, so you've got x minus 3, x plus 4, over x minus 3. Those will cancel, and you have a point discontinuity at x equals 3. So the term that cancels is the one that's gonna cause the point discontinuity. So what you guys are gonna do on the second page of your notes is just go through and figure out which type of discontinuities occur at each one of those 9 equations. So I'm gonna go ahead and stop the video, I'll get a new one started, and I'll go over those with you, but I expect that you guys will practice those on your own first. That's your classwork.